Assalamualaikum and good morning to all. Today we will explain the solution for problem 12.3. Problem 12.3? Where? You can refer to page 506 from Structural Analysis textbook by R.C. Hibler. Okay, now we are going to solve this problem by using MDM. Do you know what is MDM? No? It's okay. MDM, I will explain it to you. MDM is a displacement method of analysis that is easy to apply once certain elastic constants have been determined. It is also a method of successive approximation that may be carried out to the desired degree of accuracy. Essentially, the method begins by assuming each joint of a structure is fixed. Okay, now let's redo this problem.
Fundamental problem 12.3. Determine the moment at A, B and C, then draw the moment diagram. Assume the support at B is a roller and A and C are fixed. EI is a constant. The figure shown that there are three loadings on the joint A, B and C. For the member A and B, there are two loadings, but for member B to C, there is only one loading. First of all, we must find out the distribution factor for every member. In this case, we have 4 members. For distribution factor at AB and CB, this is 0 because they is supported at the fixed wall. And distribution factor for BA to BC, we consider they have a value. To find the distribution factor, we must find out the stiffness factor, that is K. For distribution factor at BA and BC, we must find out the stiffness factor over the total of stiffness factor distributed by the member. By the way, to carry out the distribution factor BC, 1 must be subtracted to distribution factor BA. Second rule, to find out the moment by using moment distribution method, we must consider the fixed end moment. As we can see, for fixed end moment AB, which is have two loadings, we are using 2PL over 9. So, for fixed end moment AB, we consider it's negative because it is counterclockwise. For clockwise sign convention, we consider it is a positive sign. As a result, fixed end moment for AB equals to negative 5,400 Newton meter and fixed end moment for BA equals to 5,400 Newton meter. Besides, the fixed end moment for member BC, which is have only one loading, we use PL over 8. So, we consider fixed end moment for BC equals to negative PL over 8. But fixed end moment for CB, we consider PL over 8 because for BC, there is a counterclockwise and for CB, there is clockwise sign convention. We move to the next step to find out the moment distribution method. In this step, we are tabulate the data in the table. We have 3 joints, which are A, B, and C. For distribution factor and fixed end moment, we must put all the results that we calculate before. To find out the distribution fixed end moment at the members, to find out the distribution fixed end moment for every members, we must multiply the value of fixed end moment with the distribution factor. So the result was shown in the table. After that, to find out the carryover, the distribution of fixed end moment must be divided by 2. By the way, for every joint, we must draw the cross section. As you can see here, the distribution for carryover for all the members equals to 0. After that, we sum all the value that we get from fixed end moment until distribution of carryover, so we can get the moment. As a conclusion, you can see here, before we draw the shear force diagram and bending moment diagram, we must find out the value of shear at A, at B, and at C. As you can see here, we are carry out the value for shear force at VA and VB1. The value of VA equals to 5.076. We consider upward is positive. And the value for shear force at VB1 equals to 3.924. The sign also upward as a positive value. Next, the value for shear force at B2 equals to 1.458. We consider upward is positive, and the value for shear force at VC equals to 0.542. We consider the upward positive. Lastly, we are drawing the shear force diagram. As you can see in the figure, the shear force from A to B is carried out, and the drawing is like the figure shown. For the next figure, the value for shear force at B to C, the shear force diagram is shown at the figure. Last but not least, to find out the bending moment diagram, we are combine all the moment from A to B and B to C moment that we get from the table. As you see in the figure, this is the bending moment diagram for the beam.
So, how? Do you understand? If not, I recommend you all to do more exercises. That's all from me. Thank you.